everyone. The base of a solid is bounded by the circle x squared plus y squared equals 16. We're going to find the volume of the solid with the base that has a semicircular cross sections. And it's perpendicular to the y-axis. So let's do a little sketch of this. This is a circle. Center is 0, 0. Radius is 4. 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'll just sketch a circle there. All right. So this is negative 4 to 4. This is 4 to negative 4. All right. So basically it says it has this cross section that's perpendicular to the y-axis. So I can draw it, say, right here. This is a cross section right in here. Looking at it like that. So what I want to do, since it's perpendicular to the y-axis, I want to solve for x. So if I solve for x, I have x squared plus y squared equals 16. So x squared equals 16 minus y squared, and therefore x equals plus or minus square root of 16 minus y squared. Now, the plus part is this side of the x. So this is going to be x equals a square root of 16 minus y squared. The minus part is this side of the y-axis, and this is going to be x equals negative square root of 16 minus y squared. So the length of the cross section is obtained by subtracting the left boundary, which is this side, from the right boundary. So let's do that. We're going to take square root of 16 minus y squared minus the left boundary. So that's going to be negative square root of 16 minus y squared. And this just gives us a plus here. So we have two of these. So this equals 2 times square root of 16 minus y squared. Now, since the base is this circle cross section here, the length is the diameter of the cross section. So this is the diameter of the cross section. Therefore, the radius is going to be half of this. Your radius is half. So that's going to be square root of 16 minus y squared. Therefore, if you take the area of the semicircle, if you just take the area of a circle, it's pi r squared. But if you're doing the semicircle, this right here, it's going to be 1/2 pi r squared. So for us, that's going to be substitute in your r, and you're going to get this is equal to pi divided by 2, and then you're going to square this square root, 16 minus y squared, and then you square it. So you end up getting this equals pi divided by 2 times 16 minus y squared. All right, so that is going to be the area. Now that we have that, we can find the volume of the solid. So we're going to use a formula, and this is the formula we're going to use. A of y. So we're going to go from the integral from negative 4 to 4. This is A of y. And this is going to be equal to this. Pi divided by 2 times 16 minus y squared dy. Because remember, this was your x here. A of y equals your x. All right. Now that you have that, what we can do, remember we had that circle, we can multiply it by 2. if we, just so we can make it easier, instead of going from -4 to 4, we can go from 0 to 4 if we multiply this by 2. So this is going to be pi divided by 2 times 16 minus y squared dy. And when you multiply these two, you're just going to get pi. So you get pi times the integral from 0 to 4 of 16 minus y squared dy. All right, now let's go ahead and integrate this. This is going to give us pi, and before, let me write what I had. Pi times the integral from 0 to 4, 16 minus y squared dy. So then you integrate this, you get 16y minus 1/3 y cubed, and we're going from 0 to 4. It just makes it easier if you only have to go to 0 to 4, because when you substitute in this 0, it just goes to 0. That way we only have to substitute in the 4. So we get pi, this is going to be 16 times 4 minus 1/3 times 4 cubed. All right. I can factor out a 4 cubed here because I have a 4 here. This is going to be 4 times 4 times 4, right? Because 16 is 4 times 4. So I can write this as pi, and it's going to be 4 cubed. And this is going to be 1 minus 1/3. All right. So this is going to equal 2/3. So you get 2/3 times 4 cubed times pi. And this is going to give you 128 divided by 3 pi as the volume of the base of the solid. Thank you. Have a nice day. Bye-bye.